Okay, so ladies and gentlemen, you are welcome. Let me repeat myself. If this is the first time you're coming to my YouTube, please try to subscribe and join the YouTube community so that at least you will have access to all our videos when we upload them. So in today's video is actually going to be the continuation of our video on quantum numbers. So in this point, we are going to use the set of quantum numbers and then use it to identify an element. So let's say now we have n is equal to 3, and then we have l equals to 0, and now we have s equal to plus half. So can we identify which element is this, or which of the element having this four set of quantum numbers? Of course, we can easily identify it using this. So we said n is 3. So when an element have, of course, n is 3, it means that the energy level is 3. So we have 3. And of course, when n is 0, the orbitals is s. So we have s, we have 3s. We have 3s. And then of course for the magnetic quantum number is 0. So it means that we have our s. So the magnetic quantum number is 0. So since it is s orbital already identified, and of course m is 0 for s orbital, so therefore we are now going to of course identify which of the since the spin is half, it means that the electron is pointing upward. So since the electron is pointing upward, it means that we have only one electron in s. If it is minus half here, it means that we are going to have one electron upward and then another electron downward. That is clockwise and anti-clockwise. So if it is minus here, we are going to have 2. So therefore here we have 3s1. So since here we have 3s1, then how do you identify the element? Then you are going to apply the above principle by starting with 1s2, 2s2, 2p6, 3s1. So it means that you are going to stop at 3s1, then you count the number of electrons. 1, so you have 2 plus 2, 4, plus 6 making 10, plus 1 making 11. So it's 11. So which of the elements have atomic number 11 is sodium. So the element is sodium. So let me give another example. Let's say we have n is equal to 3. Then we have, let's say, l equal to 2. Then we have m is equal to minus 2. Then we have s is equal to minus half. So which element is this? Can we identify which element is this? The answer is yes. So now, since n is 3, so we have 3. And of course, which element, if L is 3, which orbital is that? So if L is 2, which orbital is that? So if we have L is equal to 2, it means that we have d orbital. And then of course in the d orbitals, we have to draw the d orbitals. So we have minus 2. So in our, when m is minus 2, so we know that of course d orbitals generally have 5 subshell. It has 5 subshell. So we have 1, 2, 3, 4. So we have 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And remember, here is minus 2, here is minus 1, here is 0, here is plus 1, here is plus 2 in magnetic quantum number, d orbital. So therefore we have this. So since we have this, it means that we have to, since here is minus, so according to Hund's rules of maximal multiplicity, we have to arrange the element singly before pairs start taking place. So therefore, we are going to start arranging singly here 1, 2, 3, 4, 5. So since it's minus half, so all these are positive. So then the next one is the negative. So it means that we have 1 electron here in the anti-clockwise direction. So we are now going to count the number of electrons. So we have 1, 2, 3, 4, 5, 6. So we have 3d6. We have 3d6. So remember from our basic knowledge of chemistry, an element in the d orbitals, the element that have d orbitals, it falls under transition element. So which of that element is that? So we have to complete it. So how are we going to complete it? According to our principles, we have to start from 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, then 3d. Since it stopped here, then we have 3d6. We have 3d6. And remember, in writing electron configuration of transition element, you can always shorten it by condensing this, represented as an argon, because here we have 2 plus 2, 4, 4 plus 6, we have 10. And of course here 3 is 2, then we have plus 2 making 12, then plus 6 making 18. So you can just write as this argon configuration or argon core, then we have 3d6, then 4s2. So what we are going to do now, we have 18 here plus 220, then 26. So which of the elements have 26 atomic number in transition element? The answer is iron. Iron is an element that have atomic number 26. So the element here is iron. So ladies and gentlemen, I am going to give you some other elements, some other samples of the element I will give you in the group, and then you solve it and identify the element. Thank you very much.